Okay, so in this video, we're going to be talking about combining like terms. Now, this is a good topic to talk about as we start going into Algebra 1 topics, and we have to get good at combining like terms and identifying like terms. Now, before we start going into these practice problems, we have to talk about what a term actually is. And I actually talked about this in the last video. And a term is very simple. A term is just separated by addition or subtraction. So if you look at the first problem here, you can see that I'm going to have 4 terms. I have one here, one here, one here, and one here, meaning I have 4 terms. Now we have to talk about combining like terms. We're looking for things that are similar. So looking at my like terms, I have an x, and I also have a negative 4x. Those are like terms that I can combine. And then you have this 4y, and you have a negative 2y. So what I can do here, I can go ahead and combine now. So going left to right, I'm going to do x minus 4x. I get negative 3x. So negative 3x. And then I'm simply going to cross these out so I know I'm done with them. I use them up. And now I have 4y minus 2y. That's going to give me positive 2y. Okay. Now at this point here, you're left with an expression. You want to see if there are any more like terms. There are not. This is going to be the final expression, and this one is now going to be done. Okay, easy. So now these get a little more challenging as we go to number 2. There's a couple of things you could do here. You could take the 7 and you could distribute to all of your terms inside, right? You could do this here if you wanted to every single one, but that's going to be a lot of work. All right, so what I recommend you do, look for a easier path, right? Always look for the path of least resistance. Let's try to simplify this down before we distribute that 7. So looking for like terms, I have an x here, and I have a positive 5x there. I can combine those. Remember, they have to be like terms. I can't take this x and combine it with, let's say, this negative 4. Again, those are not like terms. They have to be similar. Okay, so I have an x and a 5x. Now let's look at the y's. I have a negative y and a positive y. Those are like terms. And I actually have my constants now, which are going to be negative 4. And I have positive 2. Okay, so we're going to go ahead and combine these all. So I'm going to rewrite the problem. I'll have 7 on the outside, right? And doing out these operations, I get x plus 5x. Well, that's going to give me 6x. And when I'm done, I like to cross them out so I know I'm done with them. So when I combine those, I get a positive 6x. Okay, moving on, let's do the y's. Look, I have a negative y and a positive y. Those cancel each other out. Right, so those are gone. I don't even have to write anything there. All right, that was easy. And then negative 4 plus 2, I get negative 2. So I put a negative 2 here. And again, once you're done, go ahead, cross them out so you know that you used everything up. Now from here, it's really simple. Now all I have to do is distribute the 7 to my 2 terms inside. Okay, so there we go. So I'm going to do 7 times 6, I get 42. So 42, and I do put the x there as well. The x comes along for the ride. So 42x, and then I'm going to do 7 times a negative 2, I get negative 14, okay? So at this point here, when you look at your expression, there's nothing else I can do here. These are not like terms. This one is now complete. All right, let's try some more. So here are the next 2 problems, and again, you are dealing with fractions, not a big deal. These little slash marks right here are going to be division, meaning you have a fraction there, okay? So again, what I recommend you do first, try to combine inside parentheses before you distribute. So if I look at number 3, I cannot go ahead and combine any like terms there. I'm going to have to go ahead and take this 6 and distribute inside, okay? There's nothing else I can do there. Now, with this fraction, you may see what it's going to be, or maybe you don't. If you can't see clearly what's going to happen when you multiply 6 times 2/3 x, go ahead and write it out. This 6 is really over 1. It's 6 over 1, okay? And we're going to be multiplying, so we're multiplying this by what? 2/3. Now again, I'm going to leave the x out of it for now. The x is just going to come along for the ride. So just remember you do have an x there, but for this part here, I'm just going to leave it out. So all we have to do is multiply across, right? That's what we do when we're dealing with fractions. We simply multiply across. which you could do. You're going to get 12 and then all over 3, and then 12 divided by 3 will give you 4 here. Or you can go ahead and cross reduce. So for example, I see that 3 goes into itself 1 time. I see that 3 goes into 6 2 times. I'll do 2 times 2 and get 4. And then I'll do 1 times 1 and get 1. You end up with 4 over 1, or just 4, right? And remember, you do have an x there. So 6 times 2/3 x is going to be 4x. So 4x. And again, you may not have had to do this part here, but hey, it's good to write it out sometimes. And now we're going to do 6 times 5. We get positive 30. Is there anything else we can do here? Looking at our expression, we cannot, right? That's it. No more like terms. We are done. Okay? Okay, let's try the next one. Again, see if you can go ahead and combine like terms before you go ahead and distribute that 5. Now, this one's a little bit different because you have a 4 and you have a negative 1/5. And you could combine those. Those are like terms, but look at how the problem is set up, okay? If I distribute this 5, I'll do 5 times 4 and get 20. And when I finally make my way around to this negative 1/5, look at what's going to happen there. The 5s are going to naturally cancel out there and you're going to be left with negative 1. So for this particular problem, I'm actually not going to combine these here because it's going to take more work. I'm going to have to do 4 minus 1/5. I'm going to have to get a common denominator. I don't really want to do that. This problem is actually set up where if I just distribute the 5, I'll get rid of that fraction naturally, right? So again, a different path on this problem. So make sure you're looking at all avenues before you go ahead and try to solve the problem. That said, the y's here, I am going to combine those. So I'm going to rewrite the problem. I have 5, and then I have times 4. Again, not going to do anything with that. And then y plus 2y, I get 3y, so plus 3y. Okay. And then negative 1/5. Negative 1/5. All right, so now we're going to go ahead and distribute inside, right? So I have to distribute to all of my terms inside. I have 3 total, so I'm going to all 3 here. Okay, so I'm going to do 5 times 4, I get 20. All right, and then 5 times positive 3y, I get positive 15y. So positive 15y, almost done. And then we're going to do 5 times negative 1/5. We talked about this, right? The 5s are going to cancel out. And if you're having trouble seeing how that's going to work out, go ahead and do the same setup that we did right here. Right, you'll see how that's going to work out. But the 5s are going to end up canceling out. Again, I'm dealing with a fraction and I have the same number on both the top and the bottom. That's how it works out. But again, if you can't see that, go ahead and write it out. That way, you know, it's a little more visual. But I'm going to be left with negative 1 here. Okay, when I multiply 5 times negative 1/5. Now, look to see if you have any like terms. I do. I have 20 and I have a negative 1. When I combine those, I get positive 19. So positive 19. And then plus 15y. And now when I look at the expression, there's nothing else I can do here. Okay, this problem's done. So we're going to go ahead and box it in. There is our final expression, completely simplified down, right? Okay, 2 more problems and then we're done. So here's our next set, and number 5 is kind of a fun one, right? Look what happens on 5. You don't have any parentheses there. So go ahead and try to combine like terms. Look, I have a 7x and I have a negative 7x. Okay, and then I have a positive y and a negative y. So these all cancel out. 7x minus 7x, well, that's 0. Y minus y, right, will give me 0. So I'm just left with 0 here. Okay, that's it. That is going to be the final expression there, 0. All right, that was an easy one. Now this one here, again, you're dealing with more fractions. Don't worry about it. These are not like terms inside though. I can't combine those, right? Those are not like terms. So what I have to do, I have to go ahead and distribute the 4/5 inside. So 4 over 5, I'm going to distribute to both of my terms there. And so on this one here, I am going to write it out. I have 4 over 5. So 4 over 5 times 1/5 x. Now again, I'm going to leave out the x for now. I just want to take care of simplifying down these fractions. I am multiplying, okay? So be careful on this one. The 5s will not cancel out on this one because they're both on the bottom. right? I don't have it on the top and bottom like the last problems where they cancel out. So it's really simple. You want to see if you can cross reduce. I cannot. In that case there, just go ahead and multiply right across. You're going to do 4 times 1 and you get 4. And then you're going to do 5 times 5 and you get 25. And again, you do have an x there. The x comes along for the ride. So you put 4 over 25 x. Okay? And now I want to do the next one. So again, let's go ahead and write it out so we can see what's going to happen here. I'm going to have 4 over 5 again. So 4 over 5. And I'm going to multiply by 5 over 4. So this is an interesting one, and maybe you know what's going to happen here. If I look at 4 over 5 and then I compare it to 5 over 4, that is the reciprocal. And when we multiply a number by its reciprocal, we call that the multiplicative inverse. Okay, it's a long word, fancy word, but all that means when you multiply a number by its reciprocal, we call that the multiplicative inverse because it always ends up equaling 1. And you can see how that's going to happen here, right? Cross-reducing, I see that 4 goes into itself 1 time. Same thing here, 1 time. 5 goes into itself 1 time. 1 time here as well. You can see that I'm left with 1, right? Positive 1. So I put plus 1 here. Okay, and that's it. All right? Nothing else I can do there. I don't have any more like terms. That problem is now complete. So again, that is combining like terms. I hope that you found this video helpful. I hope that you gained some knowledge from it. And again, if you could please go ahead and just give this video a thumbs up, I would greatly appreciate that. And make sure you also subscribe so you get more math videos in the future, and I'll see you in the next one.